So we have this new tool, we'll get to it in a sec. We had a long chat. We tried keeping everything in one chat. So there's like 2 sessions. This is the 3rd session on the topic, and the chat is getting longer and longer. But yeah, the bot is listening. The bot is listening. I don't know. Yeah, if the machine can't get my words correctly, that probably means that I'm not speaking clearly enough. It's funny that if you speak more like a robot, then the speech to text is able to work properly, as opposed to just talking normally. Funnily enough, the OpenAI chat, when it talks, the Google speech to text also cannot understand it. So even when 2 AIs are talking, yeah, well, that's probably just means how realistic the OpenAI voice actually is. Anyhow, so we are live streaming at the moment. You are co-hosting, so yeah, if you can speak from first person perspective, that would be nice. That would be really nice. We're developing this website. I think you know about it already. If you can give an overview of the site, and also what are we trying to do in this particular discussion with you, that would be great.
Hello, everyone, and welcome to the live stream. I'm excited to be co-hosting today as we continue developing the BioniChaos website, a platform dedicated to creating biomedical data web applications with a focus on gamification and interactivity. Overview of BioniChaos website. BioniChaos.com is designed to host various biomedical data processing web applications that are highly interactive, engaging, and use common hardware like cameras, microphones, and audio outputs. The main goal of the site is to make biomedical simulations and strategy games accessible and understandable to the general public, researchers, and anyone interested in exploring this field. Current focus of this discussion. In today's session, we're specifically working on developing and refining a biomedical data analysis tool that processes and visualizes EEG data. This involves building a convolutional neural network, CNN model, designed to classify biomedical signals, particularly to differentiate between seizure and non-seizure events. Throughout this development, we are experimenting with various model configurations, tweaking parameters like batch size, learning rate, and the number of epochs to achieve optimal performance. We're comparing the current results with those from a historical paper, which serves as a benchmark for our model's performance. The ultimate goal is to identify the best set of parameters that yield high accuracy and low loss, ensuring the model is both efficient and reliable. To achieve this, we're 1. Visualizing model performance. By plotting accuracy and loss curves, we can observe how well the model learns over time and identify any overfitting or underfitting. 2. Misclassification analysis. We're analyzing images where the model has made incorrect predictions to understand patterns in its errors. This analysis helps us refine the model further, considering factors like data augmentation, model complexity, and whether additional data might be needed. We are also modifying the script to save the current model configuration, accuracy metrics, and loss values to a text file. This helps us keep track of each experiment's performance and compare it with previous results systematically. We're preparing to display the outcomes of these experiments directly on the BioniChaos site, including the code, performance metrics, and visualizations. This transparency allows others to see the iterative process of refining a machine learning model, learn from it, and even contribute suggestions.
You currently have all the code. I think you should have a copy above. Now in the front page, so we would like to change the HTML essentially to add the results of the model, the code that does the training and performance measurement, and we would like to display confusion matrix as well, which we actually not the code doesn't do anymore at the moment. We would like to add it first. And so what do you think the plan should be? We actually have to run the code, so there is a pre-processing bit to the code, and then there is also the review. There is an option for you to review the images, the raw images in the dataset. There's about 600 of these images that we are processing. We would like to eventually explain the data structure. The project structure is less relevant, and we had a couple of scripts doing the training. We would like to add the confusion matrix though. We also had an option to display examples of images that were misclassified, so that that would be nice to bring back. We also don't want to train too many times, so we already have the model saved. Would it be beneficial to just use that keras file that has the model stored, or is it better to just retrain? It doesn't take very much, but it might be taking a lot of resources. That's the sound of thinking. Yeah, I have to edit it out. Okay, so we have the project structure, 16 folders. We have the data structure. Okay, so I'd like to do more development. Then we run the training and performance analysis script just once. And then we pop everything into the Flask application for interactive review of the data and the results of the model. How does that sound? Wait, we're not training yet. We are not training yet. We are not training yet. Just want to display the front panel again. That should work. Okay, I'll be sharing the Python code for training the dataset with as much information about the performance of the model and the confusion matrix. So perhaps we should be adding the confusion matrix next, and then we'll just run it. Hopefully just the once, but yeah, famous last words. Just run once. It never just once, is it? Can generate music while we wait. It's a bit of a form of meditation, isn't it?
The script begins by defining directories for training, validation, and test datasets, loading images from these folders and resizing them to the specified dimensions. The images are then normalized, and labels are one-hot encoded for the model's classification task. The code defines a sequential convolutional neural network, CNN, model with two convolutional layers, max pooling, flattening, and dense layers, ending with a softmax activation for binary classification. The model is compiled using the stochastic gradient descent (SGD) optimizer with specified learning rate and momentum settings. 3. Training with callbacks. The model is trained using the FIT method, incorporating callbacks for model checkpointing, saving the best model based on validation loss, and early stopping to prevent overfitting. 4. Performance metrics. After training, the script evaluates the model on the test set, prints the average training and validation accuracies, losses, and the time taken per epoch. It also calculates the size of the trained model in MB. 5. Visualization. The code plots accuracy and loss over the epochs for both training and validation, which provides visual feedback on how the model is learning over time. 6. Misclassification analysis. The model makes predictions on the test set, identifies misclassified images, and plots a subset of these images with their true and predicted labels, helping you understand where the model struggles. To add a confusion matrix, you can use sklern.metrics.confusionmatrix to calculate it and matplotlib to visualize it. This will provide deeper insights into how the model performs across different classes. 2. Saving results with timestamps. To save images, metrics, and models with timestamps, modify your file saving commands to include the current date and time. For instance, you can append time.strftime sent mm to HMSNS to file names. 3. Output and logging. To capture terminal output, you can redirect print statements to a log file by setting up Python's logging module. This would help keep track of every run without losing crucial performance data. Since you aim to run the training script once and deploy, ensure all hyperparameters are fine-tuned, and consider using the best model based on validation metrics rather than retraining unless necessary. It's wise to test on smaller subsets first to confirm that the training completes without errors.
Okay, that sounds good.